Yeah, so recently I got a math question from a friend of mine. He's doing some basic stats stuff. Let me just read the question. I'm going to work on solving the equation. It says a clinical trial test of meth is designed to increase the probability of conceiving a girl. In the study, 340 babies were born and 289 of them were girls. Use the sample data to construct a 99% interval estimate of the percentage of girls born. Based on the results, how does the method appear to be effective? So real quick from that word problem, we know that our sample size is 340. That's the total number of babies. It said 289 were girls. We're trying to find the probability of success, which would be having a girl. So to do that, we need our P value, which is going to be 289 divided by 340. That's going to equal, and I punched it in the calculator, 0.85. We also know that Q, which is equal to 1 minus P, is going to equal to 1 minus 0.85, which is equal to 0.15. So first thing we got to know is our equation for a confidence interval. This is just something, look it up real quick. You can look at this one. But essentially I wrote it down here because sometimes on the screen it looks funny. So confidence interval, this is our p-value, which is the probability of success, plus or minus our z-score, times the square root of our p-value, 1 minus p, which is q. So we can say p times q divided by n. We know that n was number of our sample size, right? So 340 is going to be equal to n. The original equation said we want a 99% interval, right? So we got to take everything that's in between these two, right? So this total amount would equal to 0.99. Sorry, I lost my tripod, right? So if we look this value up, 0.005 in the z table, we see that a z of negative 2.57 is going to be 0.0051 and negative 2.58 is 0.0049. To get 0.005, we'd be halfway, so we can just split this in the middle. And our z-score that we're going to enter over here into this equation is going to be 2.575. And we're just going to use the absolute value since we're going to do a plus and minus. Plugging the info in, we're going to have our equation look like this, 0.85, which is our probability of success, plus or minus our z-score, which we looked up, we saw was from the z-tables, 2.575, square root of p, 0.85, 1 minus p, which is 0.15, times n, over n, which we know is 340. Simplifying that, we have it this, multiplying this part out, we get 0.85 plus or minus 0.04986. And then so it's plus or minus, right? And once we do the plus or minus, we're going to see that our confidence interval is 0.8001 is less than P, our probability of success, which is less than 0.8999. That will give you a 99% confidence interval for that equation. So that tells us we'd have a 99% confidence interval would encompass between 80 and 90% of the data if we take our original n value, which is 340, multiply it by 0.8 and 0.9, we see we get 272 and 306. So to put that all together in a word answer would be we're 99% confident with this new method that we would have between 272 and 306 girls out of 340 births.